welcome to the course. First of all, thank you for taking this course. In this video, let me quickly give an overview of the course. The course structure is very simple. The course mainly has three phases. In the first phase, we will learn about behind the scene working of each peripheral like GPIO, SPI, I2C and USART. In this phase, you will learn the fundamental operation of each peripheral, its control and configuration registers, programming structure, configuring peripheral clocks, IRQs and interrupt configurations, and many other interesting things. After that, we will move to phase 2. By gaining full confidence about the peripheral in phase 1, in phase 2, start implementing a driver code for the peripheral. In this phase, let's first write the peripheral driver header file followed by the driver source code. We will populate the header file with various macros explaining the peripheral, and also we will prototype all the required APIs which needs to be implemented by the driver source code. Then I will walk you through step-by-step procedure to implement various APIs as a part of driver source code implementation. After that comes the phase 3. In phase 3, we will do testing and debugging of our implementation by writing a sample application for each peripheral. So phase 3 consists of 1. Write a sample application on top of our driver using driver exposed APIs. Here we will write separate sample application to test each and every peripheral. And the second task we do in phase 3 is testing and debugging using logic analyzer hardware and software. To keep everything professional, we not only test it on the real hardware but also get the trace on logic analyzer to analyze the behavior of the peripheral. So in this phase, I will teach you how to configure the logic analyzer, how to do connections between board and the logic analyzer, how to get the trace on the logic analyzer, and I will show you how you can decode various protocols into hex or ASCII. Also, I will discuss common problems and debugging hints and tips related to protocol like SPI and I2C. Great. To conclude this, the entire course is divided into 3 phases. The phase 1 is all about demystifying the behind-the-scene working of the peripherals. In the phase 2, we will learn about the peripheral driver development by scratch. And finally, in the phase 3, we will carry out debugging and testing. Now hang on, it's not over yet. As a part of this course, you will also get lots of bonus lectures related to bus interfaces, clocks and software setup, etc. In this course, by code implementation, I will thoroughly discuss about different bus interfaces of your MCU like HB, APB, and different clocks like H clock, P clock, system clock, PLL, etc. I will also discuss about various clock sources such as high-speed external clock, high-speed internal clock, phase lock loop, etc. Through coding, I will show you how to enable, configure, and finally how to use different clock sources as system clock to run the MCU. Also, I will teach you how you can route different clock sources to GPIOs to take measurement of different clock sources on your microcontroller. And not only this, in this course I will help you to do entire software setup, such as installing Keel MDK5 software, installing software pack for your microcontroller, creating your first Keel project, debugging, creating libraries from the Keel, etc. I have passionately created this course to bring maximum advantage to your career and to improve your knowledge in the area of embedded systems. Great. Thanks for watching this overview lecture. From the next section, let's begin with the first peripheral, that is GPIO. See you in the next video.